I welcome once again, and this is another series, another video in the series of the actual interview questions asked in Bhabha Atomic Research Center interview. As I told you earlier also, that the interview of BARC is really the epitome, or you can say the highest level of interviews which are conducted for the jobs related to technical field. BARC interview checks the in-depth knowledge and creativity and your divergent thinking. Many times, in the interview of BARC, only 2 to 3 questions are asked, but the interview is very long duration. It takes half an hour to not even half an hour, it takes 45 minutes to 1.5 hours also. There are students who will tell that my interview was approximately 1.5 hours. There are a couple of scientists who are sitting and they are giving you sufficient time to explain your concept, and they will keep on asking you question. They will start with a very basic thing, very basic question, and then they keep on increasing the depth of the questions. And many students ask, sir, what books should we read for interviews? I've got a call for BARC, so what should I study, from where should I study? My answer is that it is not the books. The books you have studied are more or less the same. It is the creativity and your own thinking that matters. They are not checking the knowledge of a particular subject, like you should give them answer. They are checking your approach. No doubt your concept should be good, your knowledge, especially for basic concepts, should be good. After that, they are going to check the approach and your thinking. Those of you who will be totally relaxed during interview and will have bent of mind to give the answer to some creative questions, think of divergent solution, think divergently and creatively, and provide the solution to such questions, will get mileage in this particular interview. So you need to be calm, you need to be confident, and you need to be creative. So be calm, be confident, be creative in the interview of BARC, and you can convert it. That is a mantra to crack the interviews of BARC. Confident, because even if you don't know some answer, you can say confidently, sir, I don't know that. Then they will ask you next, and normally they give you opportunity for couple of subjects. They ask you your five favorite subjects in engineering, technical, and then they ask you question from that. So you need to have lot of practice for answering such questions. Mock interviews, you need to go for it. As of now in India, culture of mock interview is still started. I mean, it is not there. Couple of years down the line, you will find that every student will be going for lot of mocks, and then they will prepare really good for such interviews. Now, this particular video is related to one of the questions from strength of material asked to one of the student when he said my favorite subject is strength of material. So this question was asked to him, and you will find that how the interviewer proceeds, how it goes slowly and increases the depth of questions. I will not tell what answer student gave, I will tell what answer should be there, that is what I will say, but the questions were the same. Now let's start. So the question he was asked was, what are your 5 favorite subjects? One of the subject he said was strength of material, and from there next question started coming. So next question was, in the strength of material, first question was, what do you understand by stress? Now you understand one thing, stress is not load per unit area. It is, if I give you 3-dimensional view of any body subjected to some particular loading, let us say this P is the load applied, and if we divide it at this body at some particular section, we find that at these 2 sections we will get the resistance force. This P is the load which is applied, this tensile in nature, and maybe if I can make with different color, this P is the resistance force. So this is called the resistance force induced due to the load which we applied. This P is the resistance force which is induced due to the load applied. So I applied load P, and that load eventually induced some force P in the body. Now what is the stress is? Stress is the P resistance force per unit area. Let us say cross section area is A. So this is the resistance force per unit area. So what happens is, when you apply a load or force on a body, and suppose the body resists any kind of motion or something like that. If you apply a force on a body and the body is not moving, if you apply a force on a body and body moves, there will not be any stress induced in the body. But if you apply a force on the body and body does not move or cannot move, if the body cannot move, then the resistance offered by that body is in the form of force. So which laws say that this P and this P will be equal? Newton's third law says, to every action there is equal and opposite reaction. If you apply a force on the body, body also applies force on you, that is equal and opposite. Opposite because arrow, as you can see, looks like opposite. Otherwise this is also pulling force, this is also pulling force. And the tensile stress is induced because of tensile force applied on the body. So what is the stress? Load per unit area dimensionally, but actually it is the resistance force per unit area. Next question was, how can we induce stress in the body? So I have already told you what are the methods to induce stress in the body. Apply the force. Apply force, that can be number one. Sir, if we apply a force or load on the body, that can be one way to induce the stress in the body. But you know what, before we say how can we induce the stress in the body, we should also know the stresses are of different types. There are normal stresses, as we can categorize, and then there are shear stresses. So we have different categories of the stresses, and one of the way to induce shear stress is when you apply the moment or torque. When you apply the moment or torque. So sir, these are the two ways in which I can induce the stress in the body. But what you are missing is, there is another way in which you can induce the stress in the body, that is the thermal stress. Now thermal stress is not induced either because of the load or because of the torque. I hope you have done the torsion equation also, where T over J is equal to tau over R. So the applied torque induces the torsional shear stress, and load on the beam, shear force, induces the bending stresses, shear stresses and all. So he was asking, what are the mechanism, how you can induce the stress in the body? What is the way? Sir, by applying force. Is applying force is the only way you can induce stress in the body? No sir. I can induce the shear stress also by applying the torque, which is called torsional shear stress. What else? Thermal stress is also there. Don't forget to mention thermal stress. If we apply a force on a body, does it induce the stress? Answer is not always. I apply a force on a body and the body is ready to move, then the body will accelerate. Let us say the mass of the body is m. So P is equal to mass into acceleration. So if the body is free to move, if I apply load P on the body, no stress will be induced. So if we apply force on the body, does it induce the stress? May not be. At the same time, now suppose I apply the force on the same body at some angle, same force is applied. Now what happens is, this force will have two components. One will be Py component, another will be Px component, and let us say this body is having acceleration A. Now this acceleration in the body is because of the component Px, the horizontal component of the force is inducing the acceleration, is basically accelerating the body, and that is m into A. Whereas this Py eventually is the force which is applied on the body. Now if I make the free body diagram, this Py is like, if I am not considering the mass, and even if I am considering the mass, this Py plus mg will be Py plus mg will be the compressive force applied on the body. And now you see the body is restricted to move in y direction. So if suppose he asks you, in this case what is the stress induced in the body? 0. In this case what is the stress induced in the body? Sir, the stress induced in the body is compressive stress, and the value of that is Py, y component of the force, and you can calculate that. If that is theta, then this Py is P sin theta, right? So this P sin theta plus mg, m is the mass of the body, mg is the load which is acting on the body, and this particular body, then if I divide it with the area of the body, that will be the compressive stress which is induced in the body. So yes, not every force induces the stress, only that force which is the resistance force induces the stress in the body. Now next question comes, when we apply a force on the body, suppose we apply a force on the body, coefficient of friction is mu, mass is m, limiting friction is mu into normal reaction. This is the limiting friction, you know that. The limiting friction is mu, coefficient of friction, into normal reaction, and the normal reaction acting on the body is equal to its weight, which is mg. So mu mg is the limiting friction, that is the limiting friction. Now let us say I applied a force P on the body. Let us say the force or which I applied is P on the body, right? Now let us assume that P is less than limiting friction. Then this is the case of static friction, body will not move. I applied a force P on the body and the body is resisting. The body is resisting, friction is resisting, body is not moving. Now we said that if we apply a force and the body moves, no stress is induced because it accelerates. Now I am saying if I apply a force P on the body and the body does not move, there is a resisting force which is coming into picture, and that resisting force is the friction force. Now in this case, if the applied force is less than limiting friction, then that friction is static friction, and the static friction is nothing but it is equal to the applied load itself. So the body does not move, and what is the friction in this case? Equal to P only. Now I applied a force P and the resistance force acting on the body is also P. Now tell me what is the stress induced in this case? Answer is again no stress is induced in this case. Why? Because think of mechanism of the friction. If we think of the mechanism of the friction, and let me take you to the contact surface. Which surface is contact surface? This surface is the contact surface. If I take you to the contact surface, there are junction, cold Weldner junction which are formed. These are small junctions which are formed. This is because of intermolecular attraction between two surfaces at the contact plane. Now because of these junctions, the friction resistance comes. So the resistance force which is because of intermolecular deformation, that resistance force per unit area gives you stress, but the resistance force which is because of this bond eventually does not induce any stress. These are junctions which are preventing the motion. So the force you are applying, that force is not sufficient to break these junctions, break these welded points, cold welded points, and hence body is not in position to move, but it is not inducing any resistance force within the body. If I take the cross section, if I take the cross section of the body, something like this, then in the cross section of the body you will not find any kind of resistance force within the body, and the stress is resistance force within the body per unit area. In this case resistance force is not within the body, it is at the contact surface because of the mechanism we just discussed, friction mechanism, and hence we cannot say it is going to induce the stress in the body. I hope this concept is clear. Then he goes next, he says tell us about the type of stresses. Though I discussed with you little bit type of stresses, but sir we have normally two kind of stresses, normal stress and shear stress. This is number 1, this is number 2. Normal stress further is of two type, tensile stress and compressive stress. And shear stress is also known as this. This is a shear stress. Now let me tell you, shear stress can further be induced by different ways. Shear stress can also be induced by different ways. Suppose I give you a simply supported beam subjected to shear force. I give you a simply supported beam subjected to shear force. Now this particular shear force is a tangential force, and this induces the shear stress, which is force per unit area. So shear force per unit area is the shear stress. Now there is another way. Suppose I give you a shaft and the shaft is subjected to some kind of torque. Then T over J polar section modulus tau over R. So this tau, which is T over J into R, which is the radius, is nothing but torsional shear stress. So we understood there is shear stress because of the shear force, and then there is a shear stress because of torque applied. So this is a torsional shear stress. So we have got these two type of shear stresses. Now he says, in how many ways can you induce the shear stress? You know, partially I have discussed this particular question here. In how many ways can we induce the shear stress? So I told you, one is due to shear force. Due to shear force we can induce. Number two, due to torque. This is what comes to our mind normally, that we can induce the shear stress by these two ways. Now there is something which is called complementary shear stress. This is the transverse shear stress. This is transverse shear stress. This is the average stress. Now if I give you the cross section of a beam, let us say this is the cross section of the beam, and this is the cross section. Let us say this is the load applied on the body, and let us say area of cross section, this is called transverse section. So this force per unit area is called transverse shear stress. But you also know one thing, that whenever there is a shear stress induced, which is like, say this is tau, this is tau, the body is not in equilibrium, and to bring the body in equilibrium, then you get complementary shear stresses also, and this becomes the complementary shear stress. So these two tau will become complementary shear stress. As the name shows, complementary shear stresses come into existence only when there is already the applied shear stress. So induced shear stress because of the shear force, which is called average or transverse shear stress, and then there are complementary shear stresses. One more thing, this basically complementary shear stresses, these are horizontal shear stresses, and we have studied these horizontal shear stresses in strength of material along the cross section, along the section of this beam, how the transverse, how these horizontal shear stresses behave, how these horizontal shear stresses will become maximum towards the neutral axis. So this is the average shear stress, and the reaction to these shear stresses is complementary shear stresses. So these are also induced. So you can talk about complementary shear stresses and horizontal shear stresses in this particular case. And as we know, horizontal shear stresses ka, what we get horizontal shear stresses ka, the profile is something like this. So maximum horizontal shear stress is towards the neutral axis. So if this is the section, this is the neutral axis, and towards the neutral axis you get maximum value of horizontal shear stress. How many ways can we induce shear stress? So shear force and torque. Maximum students will give this answer. And then he asks you next question. Shear stress due to shear force, torque, what is the difference? What is the difference when you induce the shear stress due to shear force and when you induce the shear stress because of torque? When you induce it because of the torque, this is called torsional shear stress, T over J over tau over R. So T over J is equal to tau over R. Now this tau is called torsional shear stress. This is called torsional shear stress, right? And torsional shear stress do not induce the complementary stresses. If there is a shaft and you apply the torque on that, the torsional shear stresses are maximum at the periphery. So what is R? R is the radial distance. So if I give you like this, if I give you the shaft and suppose I apply the torque, so this R is the radial distance. At maximum radial distance, torsional shear stress will be maximum at the outer variable. So maximum torsional shear stress is at the outermost fiber on the periphery of the shaft. And as far as the shear force is concerned, the shear force stresses because of the shear force are average stresses. Suppose this is the beam subjected to shear force F, this is the cross section of that beam, then as we know the average shear stress is equal to force per unit area. If this is area A, force per unit area is the torsion, this is the shear stress because of the shear force. These are called average or transverse shear stresses. These are called torsional shear stresses. So torsional shear stresses are basically maximum towards the fiber, but there are uniform or average stresses. Now, does torsional shear stress has complementary nature? No. The complementary stress, shear stress is not induced because of torsional shear stress. So transverse shear stress, yes, transverse shear stress, which is because of shear force that induces the complementary shear stresses. These induce the complementary shear stresses. That is something which we have already discussed. Torsional shear stresses do not induce complementary shear stresses. So you should know that these do not induce the complementary shear stress. So we are talking about here transverse shear stress and we are talking about here torsional shear stress. Torsional shear stresses do not induce the complementary shear stress, and that is the difference between the two. Now coming to, can thermal stress be shear in nature? Okay, let's try to see this now. Can you see the body of length L, modulus of velocity young E, alpha is coefficient of thermal expansion and it is subjected to temperature change delta T. What is the change in length? Sir, L alpha delta T. Okay, what is the thermal strain produced? Alpha delta T. Delta T is the change in temperature. Okay, now what is modulus of velocity? Sir, that is stress over strain, but strain we have already calculated. So what is the stress induced? Sir, E alpha delta T. Now this is the stress which is induced in this body. Can you tell me, if this temperature is temperature rise, then compressive stress is induced. If this delta T is negative, that means temperature decreases, then the tensile stress is induced in this particular body. One of the way to induce the stress in the body is thermal stress. Temperature change, आपने force नहीं लगाया, you did not apply force, you did not apply torque, because of temperature change and because of the rigid boundaries. You know, this is rigid boundary, this is also rigid boundary. That means even because of the temperature change, its length is not going to change. Now suppose delta T is rise in temperature, then this piece, this body is trying to push the wall. Wall is also going to push the particular body. So this kind of force will be applied by the body on this particular component. Why? Because now this tends to expand, but boundary is not letting it expand, and this is the stress which is induced. Now in this case it is a compressive stress. Can you draw Mohr circle for this? Many students get confused in how we have to apply the Mohr circle. But can you tell me what kind of body diagram do we get here? This is the load diagram. This is the load diagram. We are getting sigma x. And what is sigma x here? Compressive. Sigma x is E alpha delta T. So what kind of Mohr circle do we get? Sir, we get this Mohr circle, right? I don't know, I am not in position to make a very good circle, so let me make a very good circle. Yes, I think now I am in position to make it. This is the Mohr circle. So this is compressive, this is sigma x in the negative side. There is no sigma y, so 0. You understand? Now, will there be any shear stress induced here? Answer is yes. what do you see the radius of the Mohr circle? This is the maximum shear stress. And what is the value of maximum shear stress induced in this body is sigma x by 2. What is sigma x? E alpha delta t. So that is the maximum shear stress which I am inducing. So if I give you a body, if I do not apply shear force, if I do not apply torque, can I still induce shear stress in the body? Yes sir. Thermal stress can induce the shear stress. Very important question it was asked. Maximum shear stress in the previous case, yes sir. Maximum shear stress in the previous case is the radius of Mohr circle, and that is further equal to sigma principal divided by 2, that is E alpha delta t divided by 2. Yes, I got it. Now think of that body is made up of ductile material like aluminum, and you are applying the load P on this. At what plane is it going to fail? Sir, it is going to fail in the shear mode, because ductile material fail in shear mode. Let us say now this is our plane AB. This is plane AB, this is plane AD, and I give you a plane at angle theta. This is AB plane, this is AD plane. There will be a plane at 45 degree. This will be a plane at theta 45 degree. This is 0 degree. This is plane, let us say AD. This is plane, let us say AB. At the plane AB you have compressive force. At the plane AD there is no force. This is sigma x. This is sigma x. Sigma y is 0. And maximum is at theta 45 degree. So at this 45 degree ductile mode will failure. So if this material is brittle, it will fail at 90 degree or 0 degree, whatever you call at middle. If it is ductile, it will fail at 45 degree, something like shearing at the 45 degree. This is how it will fail. Now this entire session in actual will go for more than 45 minutes, because they will ask you question, you will give some answer, they will give you hint, you will proceed forward, they will talk about friction. Is friction a resistance force? Yes sir. Is this resistance force induced because of the action force? Yes sir. So whenever there is action force and then the body ke upar there is a resistance force induced, why the stress will not be there? And then you are clueless, because you never thought of that mechanism, how it happens. Shear stress in this case, what will be the maximum shear stress induced in this case? You need to understand these concepts and go. Now tell me, let me ask you genuinely, is there anything which you have not studied here for which you require the foreign author book? Answer is no. Only you need to be creative, you need to be divergent, you need to be at peace, you need to think and then answer. And that is what they want. They actually want you to think, they actually want that you should give some ideas, some input. On the basis of that, you should answer your questions. This is what is required. Hope my point is clear. Keep watching all the series of BIRC interviews. They are really fantastic, they are really good. The questions asked by them are really good, and I will present to you on the basis of the input given by my students who are going for the interviews. And yes, if you want to prepare with Europedia is the only platform and the best platform mentoring you, guiding you for interview preparation of different interviews, right? And you can take this document will be provided to you along with the videos. Thank you.